Now we're going to go over 3 examples of present value calculations. We'll start with the simplest case, a simple lump sum payment to be received at a future date. Suppose you were offered a bond. This bond will pay $1 million 10 years from today, and the risk-free interest rate is 3%. What is the most you should be willing to pay for this bond? The answer, of course, is the amount of money we would have to set aside today that could grow to $1 million in 10 years at a 3% interest rate. In this example, the future value is $1 million. 1 plus the interest rate is 1.03, and the number of time periods is 10. So our present value calculation is given by 1 million divided by 1.03 to the 10th power. Calculating the denominator, this simplifies to approximately 1 million divided by 1.344, which is approximately equal to $744,000. Now let's consider what would happen to the present value if the interest rate increased from 3% to 5%. In this case, we know that the present value of this lump sum payment would decrease. The mathematical reason for this is that a higher interest rate would increase the size of the denominator, which must increase the magnitude of the fraction. But there is also an intuitive reason why increasing the interest rate would reduce the present value of the payment. If the interest rate is higher, the money that you earn interest on grows faster, so you wouldn't need to put aside as much money in order to have it grow to $1 million in the future. Now we can calculate the present value of this lump sum payment if the interest rate were 5%. In this case, we would have 1 million divided by 1.05 to the 10th power. This simplifies to approximately 1 million divided by 1.629, which is approximately equal to $614,000. Since the interest rate affects the present value of future payoffs, it should also affect a firm's decision regarding what projects are profitable. This is because the firm always has the option to put its money in the bank and earn a guaranteed return. For instance, suppose that your firm had a business opportunity that would result in a $1 million payoff in 10 years, and suppose that it would cost $650,000 today to exploit that opportunity. In a world with a 3% interest rate, this would be a profitable venture, because we already calculated that the present value of that $1 million would be $744,000. But what if the interest rate increased to 5%? Well, now the present value of that $1 million would only be $614,000, which is less than your costs. In this case, you could make more money by just putting the money in the bank for 10 years than by investing it in your business opportunity. Of course, much of the time, a firm isn't interested in single lump sum payments. Often, a firm expects to receive a series of payments over a number of years. We call such a series of payments a cash flow. As an example, suppose that you had the opportunity to purchase a silver mine. The mine is expected to pay $500,000 today. By today, I simply mean that you would receive this money before there would be time to earn interest on any money that you set aside. 1 year from today, the mine would pay $1 million, and in 2 years it would pay another $750,000. Assuming a 4% interest rate, what is the most you should be willing to pay to buy the mine? To answer this question, we need to find the present value of the mine's cash flow. We can find the present value of a cash flow by calculating the present value of each payoff in the flow, and then adding those present values together. Here I've labeled each present value with an index indicating the number of years in the future the payoff will be received. The index of 0 represents a payoff in the present. The present value of your first payoff is $500,000 divided by 1.05 to the 0th power, which is equal to $500,000 divided by 1, or $500,000. The present value of our second payoff is 1 million divided by 1.04 to the power of 1, which is equal to $1 million divided by 1.04, which is approximately equal to $962,000. And the present value of our second payoff is $750,000 divided by 1.04 squared, which is approximately equal to $750,000 divided by 1.082. This is approximately equal to $693,000. Adding these present values together gives us the present value of the cash flow, which is approximately $2,155,000. Being able to calculate the present value of a cash flow is useful because it allows a firm to compare different revenue streams with a single metric. For instance, suppose you had two business opportunities. The first would be to acquire an existing product that will generate the same revenue each year for quite some time. This opportunity is represented by the blue line on the graph. The second opportunity, represented by the red curve on the graph, would be to launch a new product that you believe could eventually sell better than the existing brand. It would take some time for the product to establish brand recognition, so you expect sales to start relatively low, but grow over time. For the first 4 years, these revenues would be lower than if you bought the established brand, but after that, the revenues would be substantially higher. By comparing the present values of these two cash flows, we could see whether the high future payoffs of launching a new brand are worth the low initial sales. Let's consider a simple example of comparing cash flows. Here we have two business opportunities. The first will generate 3 payoffs of $100,000, and these payoffs will come 1, 4, and 7 years in the future. The second opportunity will also generate 3 payoffs, but the first 2 will be rather small, while the last will be substantial. Opportunity 2 will pay $10,000 in 1 year, $25,000 4 years from now, and $300,000 7 years from now. Assuming a 5% interest rate, which would be more valuable? It's obvious that Opportunity 2 will pay out more money over the course of 7 years. But since you wouldn't receive most of that money for 7 years, it is not obvious that Opportunity 2 has the greater present value. Let's calculate the present value of each cash flow. For Opportunity 1, the present value will be the sum of 100,000 divided by 1.04, 100,000 divided by 1.04 to the 4th power, and 100,000 divided by 1.04 to the 7th power. These work out to present values of approximately 95,000, 82,000, and 71,000, for a total of about $248,000. For Opportunity 2, we divide the payoffs by the same denominators, since they would be occurring in the same years. This gives us present values of approximately 9,500, 20,500, and 300,000, for a total of about $243,000. So we can see that Opportunity 1 is the more valuable option, even though Opportunity 2 will pay out more money over its life cycle. Occasionally, a student will ask if they should prefer Opportunity 2 if they are very patient. After all, if they are willing to wait for 7 years, they will earn more money with Opportunity 2. But this is overlooking something important. You always have the option of taking your payoff in a given year and putting it in the bank. So if you pursued Opportunity 1, when you received your first $100,000 payout, you could put $90,000 of it in the bank and let it collect interest for 6 years. Similarly, when you received your second $100,000 payout, you could put $75,000 of it in the bank and let it collect interest for 3 years. Then in the 7th year, you would have your last $100,000 payout, plus you could withdraw your money from the bank with interest. Altogether, that would be a little more than $307,000. So Opportunity 2 will give you payoffs of $10,000, $25,000, and $300,000 after years 1, 4, and 7. But you could use Opportunity 1 to construct a series of payoffs of $10,000, $25,000, and $307,000 in the same years. One last lesson to draw from this example is that the order of the payoffs matters. Suppose you figured out a way to switch the second and third payoffs in Opportunity 2. That is, you would get $300,000 after 4 years and $25,000 after 7 years. In that case, the present value of this cash flow would go up substantially because you wouldn't have to wait so long to get the big payout. As you can see on this slide, switching the second and third payoffs raises the present value of Opportunity 2 to about $274,500, making it the more valuable payoff. The point here is that a firm can create real value if it can figure out ways of moving future payoffs closer to the present. This is true even if the total amount earned over the life of the cash flow stays the same. It may even be true if the total amount earned over the life of the cash flow decreases somewhat.